Right, so the lesson objectives for this lesson are basically, for grade E students you should be able to integrate polynomials, for grade C students to be able to integrate negative or fractional powers, and grade A students to be able to use boundary conditions to find the arbitrary constant. In particular, we will be focusing on finding that arbitrary constant. So we're on page 70 of the notes, section 28, boundary conditions. Now basically, in the previous lessons we've been looking on how to integrate. Now, in these cases we got a plus c, an arbitrary constant, because when differentiating, all constants differentiate to 0. So when integrating, we had no way of knowing what that constant was that differentiated to 0. However, if we're given a point on the curve, we can find out what plus c actually is. So in this example 1, the curve C with equation y equals f of x passes through the point 1, 2. So we're given a point on the curve, so we know that for the curve we have a x equals 1, y equals 2. Now we're also given that dy dx equals 4x cubed minus 3x squared plus 3, and we're to find the equation of the curve C. So we need to go to y equals from dy dx equals, we need to integrate. So as we did before, to integrate we add 1 to the power and divide by the new power. So we end up with 4x to the power of 4 over 4. 3 plus 1 is 4. Minus, we've got 3x squared, the power is 2, add 1. We get 3, divide by the new power. So 3x cubed over 3. And then we've got the constant 3 on its own. Now we've talked about two ways of thinking of this. We can either think of it as 3x to the 0, add 1 to the power. We get 3x to the 1 over 1. Or we can think of it as undoing, differentiating 3x, the gradient of 3x is 3, and if we're undoing that gradient, the gradient's 3, so that must have come from 3x. And we get plus c, being that plus c in this case is the arbitrary constant, and not to be mixed up with the curve c. Fortunately, these sort of questions often have that what's known as an abuse of notation, using c to represent two different things. Now we can simplify that equation as 4 over 4 is 1, so we just get x to the power of 4. 3 over 3 is also 1, so we get x cubed. But the other bits, the 3x and the plus c, we can't simplify. Now the most common error in these sorts of exam questions is that people stop at that stage, therefore cutting off their chances of getting the rest of the marks for the question. This is the point where the x equals 1, the y equals 2 comes in. So we substitute those two values into our formula. So 2 equals 1 to the power of 4 minus 1 cubed plus 3 times 1 plus c. So we have 2 equals 1 to the power of 4 is 1, minus 1 cubed is 1, so 1 minus 1 cancels out. 3 times 1 is 3, so 2 equals 3 plus c. Take 3 from both sides, minus 1 is equal to c. Now you must be careful to note that this isn't the final answer to this question. The question didn't say find the value of plus c, it found the equation of the curve c. So the curve c, we have to go back to the equation we got after simplifying the integrated function, and rewrite that equation but with our c filled in. So y equals x to the 4 minus x cubed plus 3x minus 1. That's the equation, that's the answer to this question. Now in integration in C1 there will be two questions. One will be the integral sort of the last question where we leave the plus c in, and one, which is usually later in the question and worth much more marks, will give us some sort of information about a point that will allow us to find the plus c. Now here's a second example. The curve C of equation y equals f of x passes through the point 4, 5. So we've got in this case x equals 4, y equals 5. Given that f dash of x equals x squared minus 2 all over root x, find the equation of C. So this is a much more difficult question because the function we need to integrate is not in a form that we can immediately integrate. So we're going to need to rearrange it first, so it's going to take us more work. So f dash of x equals, now as I've said several times, there'll be somewhere in the differentiation or integration where we need to break down a fraction like this. So what we need to do, there'll only ever be one term in the denominator, so that we can just break it down into x squared over root x, and root x is the same as x to the half, minus 2 over root x, again, root x is x to the half, and now we can use indices laws to simplify. So x squared over x to the half is x to the 2 minus a half, so indices laws means we subtract, minus 2. Now when we bring up a power of x in the denominator, the power becomes negative, so it's 2x to the minus a half. And then subtracting those powers, 2 minus a half is 3 over 2. Remembering that in C1 we tend to prefer top heavy fractions. So we have x to the 3 over 2 minus 2x to the minus a half. Now we're able to integrate term by term. So increase the power by 1, well x to the 3 over 2, if we add 1 to the power, the way to do that with fractions is to add the denominator to the numerator. So we have x to the 5 over 2, 3 plus 2 is 5, divide by the new power, so divide by 5 over 2, minus 2x, add the denominator to the numerator, minus 1 plus 2 is plus 1. So we get 2x to the half, divide by the new power, divide by a half, and then we're integrating, so plus c. Need to simplify. Now to divide by a fraction from GCSE is the same as multiplying by the reciprocal of that fraction or the fraction flipped over. So we've got 2/5 x to the 5 over 2 minus a half times 2 x to the half plus c. And now the only simplification we can make there is a half times 2 is 1, so they nicely cancel. So we have that f of x equals 2/5 x to the 5 over 2 minus x to the half plus c. Now we go back to our boundary conditions. X equals 4, y equals 5. So y is f of x, so 5 equals 2/5 times 4 to the 5 over 2 minus 4 to the power of a half plus c. And again, we're going to need to know our indices rules to be able to work out 4 to the 5 over 2 and 4 to the half. Now, start with 4 to the half. As we did earlier on, the power of half is the same as the square root. So that's the square root of 4. And therefore, 4 to the power of 5 over 2 is the square root of 4 all to the power of 5. So we have 5 equals 2/5 times 2 to the power of 5 minus 2 plus c. So 5 equals 2/5. Now 2 to the power of 5 in non-calculated way, you can use your fingers. 2, 4, 8, 16, 32. So it's 2/5 times 32 minus 2 plus c. 2/5 times 32. 2 times 32 is 64, so that's 64 over 5. Therefore, it makes it easier if we turn all our numbers into fractions over 5. So 2 is 10 over 5. And 5 is 25 over 5. With a common denominator, we're able to calculate those fractions. So we have 64 over 5 minus 10 over 5 is 54 over 5. And then take 54 over 5 from both sides. You're going to get c is equal to negative 29 over 5. And again, that means our final answer, we have to go back to the original. So we have it at the top here, f of x equals 2/5 x to the 5 over 2 minus x to the half minus 29 over 5. And that's it.